Okay, so now we will try to do the problem that was just shown to us in MATLAB. Okay, so we have 3 points in the, in three-dimensional space. All right, so remember that the first thing we needed to do was we had to create vectors, PQ and PR. Okay, so we're creating two vectors in the plane. Okay, we're going to favor point P. We're going to use that as our vertex point. So let's find PQ. So to find PQ, we're going from P to Q. To go from 3 to 1 in the x direction, you have to go -2 units in the x direction. To go from -2 up to 0, you have to go +2 in the y direction. And in the z direction, you go from 2 to -1. That's a decrease of 3. Okay, so if we were to add PQ onto P, we should in fact get point Q. So let me just double check. It looks like we did that correctly. Okay, likewise, we could find a vector connecting points P and R. So that would be vector PR. To get from 3 to 2 in the x direction, that would be -1. To get from -2 to 4 in the y direction, you would have to increase by 6. And to get from 2 down to 1 in the z direction, you have to go down by 1. If we add PR onto P, we should get vector R, or I'm sorry, point R. So let me just check my numbers. It looks like that's good. Okay, so those are two vectors which are guaranteed to be in the plane because they connect 3 points that are in the plane. Now, the next step is generate generate a normal vector. Generate a vector perpendicular to the plane. Perpendicular to the plane. Sorry, the handwriting's off a bit. So let me actually let me just clean that up. Perpendicular to the plane. Okay. Well, we're guaranteed the cross product of two vectors in the plane will be perpendicular to the plane. So n is a particular n vector could be found by crossing PQ into PR or PR into PQ. You'll just get the opposite answer. In the end, everything will work out the same way. Okay, so if I do PQ cross PR, all right, I better set up my I, J, K, and let's put in vector P, which will be, or PQ, that'll be -2 to -3, and vector PR, -1, 6, -1. Let's put that in brackets here, and then let's just replicate it. I, J, K, -2 to -3, -1, 6, -1. Okay, so we can do our little diagonals. Okay, so our positive diagonals, it looks like we have, first we'll get -2i. Okay, the next diagonal looks like a +3 j, and then the next diagonal will be a -12 k. So those were the positive diagonals. We're going to need to subtract, let's do this in green. Let's subtract the backward diagonals. Okay, so that's -18i. Okay, this will be 2j. Remember, we're going to subtract that, and then we'll have -2k. All right, and to get this, these quantities in unit vector form, when I subtract the top from the bottom, it looks like -2 minus -18 is 16 in the I direction. Okay, 3j minus 2j leaves me +1 in the j direction. All right, and -12 minus -2 becomes -10, I believe, in the k direction. We'll add 2 on. So this is the normal vector. All right. Now we're guaranteed that that is perpendicular to the plane. All right. Now what we need to do is we have to generate generic vectors. Generate generic vectors from P. Okay, and let me just write down P was 3, -2, 2. Okay, so these could go out to any point in space. Q would be X, Y, Z. Oh, actually, I better come up with a letter besides Q because we've already used Q. P, Q, R, we'll use S. Okay, so S would have coordinates X, Y, Z. So generic vectors would be PS. That would be X minus 3, comma, Y plus 2, comma, Z minus 2. Okay, so that would represent all vectors in space coming from point P. Okay, now we want to eliminate, we only want to consider the points that are in the plane. Okay, so this is the key condition. To be in the plane, okay, N dot PS must be 0. Okay, so we only, we want to eliminate all X, Y, Z values that don't make this true. Okay, to be in the plane, this has to be true, right? So let's take N. Now, right now it's in unit vector notation. I'm going to put it into component form. 16, that would be comma 1, comma -10 in component form. When we dot that into X minus 3, comma, Y plus 2, comma, Z minus 2, that needs to give me 0. Now this is a dot product. So I will multiply the X times the X, all right, the Y times the Y, and the Z times the Z. All of the other products, there would be 9 products in general we talked about in class, but 6 of them would give me zeros because only the II, the JJ, and the ZZ terms will give me values that are non-zero. Okay, so when I do this dot product, I will get 16 times X minus 3 plus 1 times Y plus 2 minus 10 times Z minus 2, and that has to equal 0. Okay, so you'll notice I get 16x minus, let me get this right, 30 and 18 minus 48 plus Y plus 2 minus 10Z plus 20 equals 0. Now let's combine like terms, 16x, let's do the Y minus 10Z. And then let's take the other things to the other side. So we'll get 48 minus 2 minus 20 over here. Okay, so what goes onto that side? 16x plus y minus 10z should equal 48 minus 2 is 46. So it looks like 26 should be our final answer. Let me just check what we had in MATLAB here. I believe that is, in fact, what we have in MATLAB. Okay, MATLAB puts the number 1 in front of the y, but this does, in fact, match what we were expecting.